Jai Hind students, welcome to my YouTube channel. Being a student can be real hard. We as teachers have also gone through the same phase, right? At times a student may lack motivation. He may lack inspiration. He may not understand where to start and when to start. But students, please believe me, once you start getting inspired, once you get the feeling of motivation, then you also don't know what things you are capable of. You can do some miraculous things as well. So please have confidence in your abilities and never ever hesitate to put in concentrated and dedicated effort. With that, students, let's start with today's session. Today we'll be discussing vectors and types of vectors. It's a very basic session where we'll be discussing about the types of vectors. As we are already aware, all the measuring physical quantities can be broadly classified into two types. One are scalar quantities, the other are vector quantities. There are also tensors, phasors, but those quantities which have got only magnitude but no direction are known as scalars. While on the other hand, we are aware physical quantities having both magnitude as well as direction, they are known as vector quantities. And students, vector quantities are represented by either a bold letter or a letter above which an arrowhead is represented. Like velocity, as we are aware, velocity is a vector quantity having both magnitude as well as direction. So it can either be represented like this, bold letter V, like this bold letter V, or it can be represented in this particular manner, right? This bold letter V represents that velocity is a vector quantity, or you can write it like this, and over the letter V you can indicate by an arrow indicating that this physical quantity under consideration is a vector quantity, right? So arrow, students, as you are aware, the starting point, the initial point, that is known as the tail. This is an arrow. This is known as the tail of the arrow. It is known as tail. While on the other hand, the arrowhead, that is known as the terminus. That is the terminal point. That is the end point. This is the arrowhead. This is the arrowhead, which actually represents end point, end or terminus or terminal point. Right, students? And normally, while representing vectors, normally the length of the arrow that represents the magnitude of the physical quantity under consideration, and the arrowhead represents the direction of the physical quantity which it represents in the normal scenario, right? So anyways, let's start with the type of vectors. These are the different types of vectors which we will be discussing in this particular session, right? Let's start with equal vectors. Now students, as it's pretty clear, equal vectors means two or more vectors can be said to be equal vectors if they have the same magnitude as well as same direction, right? So equal vectors. Let's start with equal vectors. So what is the mandatory condition? Equal magnitude and same direction If these two conditions are satisfied, then the vectors are said to be equal vectors, like this. A vector is equal to B vector. Suppose this is A vector, this is B vector. If I write A vector equals to B vector, it means that both the vectors are of equal magnitude as well as they are directed in the same direction, right? Vector, students, I told you, it has got two parts, magnitude and direction. When both magnitude and direction of the two vectors are same, it is only then the two vectors under consideration are said to be equal vectors. Clear, students? Okay. Second, negative vector. Now look, two vectors are said to be negative of each other if they are of equal magnitude but are oppositely directed. That is, the angle between them should be 180 degree. They must be oppositely directed but must be of equal magnitude. So the two conditions are, they must be of equal magnitude, and second condition is they must be oppositely directed. So these are the two conditions for a vector to be negative of another given vector, right? So if I say A vector is negative of B vector, this equal signs indicates that both are of equal magnitude. That is, magnitude of A is equal to magnitude of B. But this negative sign suggests that both are oppositely directed. That is, the angle between them is 180 degree. So diagrammatically you can represent it like this. If this is A vector, then this will be B vector. Both represented by arrows of equal lengths but directed in the opposite direction. Angle between them is 180 degree. So that's negative vector. Right, students? Okay. Let's consider the third one. Co-initial vectors. It's pretty evident from the topic itself. Co-initial. Co means with, together. Initial means starting point. Two or more vectors can be termed as co-initial vectors if they have the same common starting point. What I mean to say is that, suppose these are different vectors. They can be of same magnitude or different magnitude, right? These are different vectors. What's one thing common in these vectors? That their tail coincides at a given point. So all these vectors have the same starting point, have the same initial point, that is point 2. So these vectors are known as co-initial vectors. So vectors having the same starting point, same or common starting point or initial point are known as co-initial vectors. Right? Simple. Okay. Fourth one. Coplanar vectors. Now look, students, it's the plane of whiteboard. So whatever vectors I am drawing on this board will be naturally lying on the plane of the board. So they all vectors which are lying on the same plane may be termed as coplanar vectors. Coplanar vectors lying on the same plane. Same plane. Vectors which are lying on the same plane are known as coplanar vectors. Like, I'll try to draw a diagram. This is a plane, maybe a horizontal plane, and here you draw these vectors. A vector, this is B vector, this is C vector, this is D vector. All these vectors may be of equal magnitude or unequal magnitude. It may be in the same direction or opposite direction or inclined at an angle between them, right? But the common point is all these vectors, A vector, B vector, C vector and D vector are lying on the same common plane. And that is the reason why these vectors are known as coplanar vectors. Clear, students? So, we are done with equal vectors, negative vector, co-initial vector, coplanar vectors. I'll repeat. Equal vectors means vectors having same magnitude and same direction. Negative vector means two vectors. They can be said to be negative of each other only if they are of equal magnitude but different direction, opposite direction. Right? The angle must be 180 degree between them. Co-initial vectors means those vectors which have the same common initial point. They are known as co-initial vectors. While coplanar vectors are those vectors which lie on the same common plane. They are known as coplanar vectors. Right? Let's start with fifth one. It is collinear vectors. Now, in order to explain collinear vectors, let me try to convince you with the help of this diagram. these are all collinear vectors. This is A, this is B, this is C, and this can be D. We can write it like this. They can be of equal magnitude or unequal magnitude, like this. Right. All these vectors are collinear vectors. So students, please concentrate on these diagrams. They are the set of collinear vectors. So what do you observe from this diagram? For the vectors to be collinear, the magnitude of the vectors can be equal or it may be unequal. Here they are of equal magnitude, but here they are of different magnitude, right? Second is, they can act along the same direction or they can act in the different direction. There can be other diagram as well. It can be like this as well. Right? So these all are set of collinear vectors. So students, from the diagram it's pretty clear. For the vectors to be collinear, first, they can be of same magnitude or different magnitude. Second, they can act along the same straight line, either in the same direction or in the opposite direction. Third, they can also act parallel to each other or anti-parallel to each other. So all these vectors, all these diagrams represent the set of collinear vectors. So, what about the definition of collinear vectors then? Collinear vectors are those vectors which may or may not be of equal magnitude, which may act along a straight line or can act along parallel lines in the same direction or in the opposite direction. So such vectors are known as collinear vectors. So for vectors to be collinear, first point is may be of equal or unequal magnitude, and the angle between the vectors can be either 0 degree or the angle between them is 180 degree. Can act along a straight line or parallel line. Clear students? Along the same direction or in the opposite direction. So accordingly, the angle between the collinear vectors may be either 0 degree or 180 degree. And remember, they can be of equal magnitude or unequal magnitude. They can act along the same straight line in the same direction or in the opposite direction, or they can act along parallel lines, again in the same direction or in the opposite direction. So I hope it's clear. Collinear vectors, right? Okay. Next is fixed vector. Now fixed vector. Fixed vector is also known as localized vector. It is also known as localized vector. Why it is known as fixed vector? Because it has point of location. Its tail is fixed. So that is the reason why it is known as a fixed vector. Best example is a displacement vector or a position vector. The position vector, its tail will remain fixed to the origin. Displacement vector, its tail will remain fixed to the initial point. So that vector whose tail remain fixed at a particular point or which has a given location, that is known as a fixed vector or a localized vector. Clear students? And as I have told you, examples are displacement vector and position vector. Seventh, the opposite of this fixed vector, that is free vector. So it is also known as non-localized vector. It is also known as non-localized vector, right? Fixed, antonym of fixed is free. So its tail is not fixed and it do not have any sort of location. So the best examples of free vectors are momentum vector, force vector, impulse vector. So these are the examples of free or non-localized vector. The term itself expresses the same thing which I am stating. in the definition, right? Fixed vector are those vectors whose tail are fixed and they have a particular location, that is displacement vector, position vector. While on the other hand, free vector, they don't have any fixed point. The tail do not remain fixed at a particular point. Instead, they do not have any location. Clear, students? So examples of free or non-localized vectors are velocity vector, momentum vector, force vector, impulse vector. These all are the examples of free or non-localized vectors. Clear? Okay, so we are over with collinear vectors, fixed vector and free vector as well. Now let's discuss polar vectors. Now students, polar vectors. These are the vectors whose direction is along the direction of motion of the body. And they have a point of application. They act at a point of application, isn't it? And these are the vectors which are directed along the direction of motion of the body. So polar vectors. This is the 8th one. Polar vectors. Like a body is moving along a circular path, maybe along this direction, and this is the axis. This is the axis of rotation. Now suppose the body is moving in the anti-clockwise direction. At an instant, you are aware its directional motion would be given by drawing a tangent at that particular point, isn't it? The displacement vector would be again along this direction. The velocity vector will be along this direction. Momentum vector will be along this direction, isn't it? So basically, the direction of velocity vector, momentum vector, or for that matter, displacement vector at a point will be given by drawing a tangent in case the body is moving along a curved path. So these vectors are directed along the direction of motion of the body. So these vectors are known as polar vectors. So the example of polar vectors are velocity vector, momentum vector and force vector, right? These are the examples. Velocity, momentum, force, etc. These are the examples of polar vectors, right? On the other hand, axial vectors. Axial, as the term suggests, these are the vectors which acts along the axis of rotation of a body. Axial vectors, actually these are the vectors which sometimes are also known as pseudo vectors. They are used in rotational motion when a body rotates about a given axis, like this is the axis of rotation. So axial vectors acts along the axis of rotation. They don't have any point of application. While on the other hand, polar vectors does have a point of application. But axial vectors which act along the axis of the rotation do not have any point of application. So axial vectors act along this axis. So these are the direction of the axial vectors. So axial vectors are those vectors which always acts along the axis of rotation of a body. Depending on whether the body is rotating about the axis in the anti-clockwise or clockwise direction, the direction of the axial vector along the axis will be either upward or in the downward direction. Right, students? So these are the vectors, axial vectors, which do not have any point of application. So the examples of the axial vectors are torque. This will study in rotational motion. Then angular momentum. Then angular acceleration. Then angular velocity. All these vectors acts along the axis of rotation of the body, and accordingly they don't have any point of application and are known as axial vectors. Right? So we are over with polar vectors and axial vectors as well. Now let's discuss position vector. Now, as the term suggests, position vector is a vector which represents the position of a moving body with respect to the origin. Suppose this is x coordinate, this is y coordinate, and this may be z coordinate. Suppose the body is moving in space in 2D or in 3D. Suppose the body is initially at this particular point, initially at t equals 0. So its position vector would be represented like this. This is r1 vector. R1 vector represents the position vector of the particle at instant t equals to 0 when it is at point A. At some later instant, the body starts moving and it reaches point B after t equals to t. So now the position vector of the same body at some different instant would be represented like this. This is R2 vector. R2 vector is the position vector of the same particle at some later instant when it is at position B. So look, position vectors, its tail always remain fixed at the origin. So a vector which represents the position of a moving particle with respect to the origin, that is known as a position vector. Right, students? Okay, then displacement vector. Displacement, as we are aware, it is the distance in a particular direction. And displacement vector is a vector whose tail must coincide with the initial position and arrowhead must coincide with the final position. So here, what would be the displacement vector? It would be given by drawing a straight line. AB, this represents displacement vector. S vector, this represents displacement vector. So the tail of the displacement vector must coincide with the initial position, and the arrowhead, which is the terminal or the end point or the terminus, that must coincide with the final position of the body or the particle. So here AB vector or S vector, it represents displacement vector. It represents displacement vector. Clear, students? Now in case the initial and the final position coincides, that is A vector or B vector, then it will be null vector. Displacement will be 0. This we'll discuss. Right? So we are over with displacement vector. Now let's consider null vector. This is what I am going to discuss now. Null vector. It is also known as zero vector. Null vector is also known as zero vector. So, any vector having zero magnitude, and since the vector is having zero magnitude, its direction can be considered to be arbitrary. So that vector is known as a null vector. That is, null vector has zero magnitude and direction arbitrary. Right? This is the property of a null vector. Now there are some other properties of null vector as well. Right? So first property is, if a null vector is added or subtracted from any other vector, then the result will be the vector itself. That is, A vector plus null vector, it will give us A vector. A vector minus null vector, it will again give us A vector. So a null vector, when added or subtracted from a given vector, will result into the same vector. Clear, students? Second, when a vector is added with the negative of its vector, then the resultant is a null vector. That is, A vector plus its negative vector would be written as minus A vector. It will be equal to null vector. Third, when two equal vectors are subtracted, then it results into a null vector. Like A vector and this is A vector. Both are equal vectors. When they are subtracted, then it will result into a null vector. Clear, students? And null vector, when multiplied by a real number, it will again result into a null vector. So fourth, if a null vector is multiplied by any real number, n is any real number, so it will again give us null vector. Clear, students? Okay, so we are over with null vector as well. It is a vector which is also known as zero vector, and as the term suggests, it will be a vector having zero magnitude and any arbitrary direction, right? Okay, next is unit vector, last one. Unit vector means having magnitude of unity. Unity means 1. So let's discuss this unit vector. This concept of unit vector, which we'll be making use of frequently. So, unit vector. Now look, as I've told you, students, any vector, it has got two parts. One is the magnitude, the other one is the direction, right? So, suppose this is a vector. It has got two parts. One is magnitude, this is magnitude, and the other part would be direction. And its direction will be represented, can be represented like this, a cap. This symbol is known as cap or caret or hat. This symbol, it is known as caret or hat. This represents the unit vector. So what I mean to say is that a vector, it obviously causes two things. One is the magnitude, the other one is the direction. So the direction part, that is known as the unit vector of a given vector. So unit vector basically represents the direction of a given vector. Here a cap, that represents the direction of a vector. Right? Similarly, b vector, it will have magnitude and direction. So this is b cap or b caret or b hat. This is the unit vector which represents the direction of b vector. Clear, students? So unit vector represents only the direction of a given vector. So its magnitude is always equal to unity. Unity means 1. That is the reason why it is known as a unit vector. Right? Another definition. Now look, over here, what we can write is a cap. Over here, a cap. It can be written as a vector divided by magnitude of a. Similarly, over here, b cap, which is unit vector b, or b cap, b caret or b hat. It can be written as b vector divided by its magnitude, isn't it? So, unit vector may also be defined as the vector divided by its magnitude. Unit vector may also be defined as the vector divided by its magnitude. Any vector when divided by its magnitude will give us unit vector. A unit vector only represents the direction of the given vector. Clear, students? Its magnitude is always 1. So, a cap, its magnitude, b cap, or for that matter, any other unit vector. Unit vector means it has to be represented like this symbolically. It has to be represented by cap, caret or hat, or x cap. The magnitude of any unit vector is always equal to 1. That is unity. Clear, students? And here I must mention, in the coordinate system, we make use of I cap, j cap and k cap, which represents the unit vector along the direction of x-axis, y-axis and z-axis respectively. Suppose this is x-axis, this is y-axis and this is z-axis, right? So the direction of x-axis is represented by I cap. This is a unit vector. Direction along y-axis, that is represented by j cap. And this direction along z-axis, that will be represented by k cap. So students, remember, I cap, j cap, k cap are the unit vectors which represents the direction along x, y and z axis respectively. Okay, now students, minus I cap. Minus I cap is a unit vector which will obviously represent direction along negative x axis. If this is positive x axis, then negative x-axis, it will be represented by minus I cap. Similarly, j cap represents the direction along positive y-axis. So minus j cap will represent the direction along negative y-axis. And in the same manner, k cap, it represents the direction along positive z-axis. So minus k cap, that will obviously represent the direction along negative z-axis. Clear, students? So I cap, j cap, k cap are the unit vectors which represents the direction along x, y and z axis respectively. And since they are unit vectors, therefore each of these unit vectors will have magnitude of unity. Clear, students? So these are the three unit vectors which we'll be making use of very frequently in the coming sessions, right? I cap, j cap and k cap. So students, in this session we have discussed about vectors, we have discussed about these various types of vectors, right? So there are different physical quantities as well, like vectors, scalars, as well as tensors and phasors. Now look, there are some physical quantities whose direction are not specified and they have got different values in different directions. Such quantities are known as tensors, right? And best example is stress, pressure. These are the examples of tensors. While on the other hand, there are some other physical quantities as well which vary sinusoidally, means its magnitude keeps changing continuously with time and changes its direction periodically, right? So these quantities are said to be of sinusoidal nature. So these quantities, when represented in the vector form, are known as phasors. This also we'll discuss in some later section. And students, one more thing I would like to share. We are aware that all the vector quantities, they must possess magnitude as well as direction. But the vice versa may or may not be true. What I mean to say is that all those quantities which possess both magnitude and direction may or may not be a vector quantity. Right? I'll give you examples. Right? Current, electric current. We are aware it flows from higher potential to lower potential. That's the direction of the flow of current. So although direction is associated with current, but still it is not treated as a vector quantity. It is because while adding currents, we make use of laws of algebraic addition. We don't add currents vectorially. Clear, students? So with that, let's conclude this session and do join me in my next lecture. Till then, students, do take very good care of yourself and be happy. Thank you.